Then the capacitance of a parallel plate capacitor increases from 5 microfarad to 60 microfarad when a dielectric is filled between the plates. The dielectric constant is dash. Okay. Now we are having the word capacitance. Okay. So first word, the capacitance of the conductor is defined as, the capacitance of the conductor is defined as the ratio of charge to the potential developed in it. And its unit is farad. Okay. And its practical units are microfarad and picofarad. Okay. So from that we can go for principle of capacitor. Principle of capacitor. So what is principle of capacitor? Let us consider a wire A and it is positively charged. Now nearby the plate or nearby the wire A, so we are placing another one, 1, 2, 3, 4. So the negative charges will be induced in the inner side of the plate B and the positive charges will be induced on the outer side of the plate B. The negative charges which are inside the plate B decreases the potential of A, so thereby we are increasing the capacitance of A. At the same time, the positive charges on the outer side of the plate B increases the potential, thereby capacitance decreases. So we need to increase the capacitance so that the outer plate is grounded. Okay, so that we can store positive and negative charges. So capacitor or condenser is a device used to store the charges. Okay, so capacitance of parallel plate capacitor. Capacitance of parallel plate capacitor. So the same thing when we consider a plate A and the plate B. The plate A is given with the positive charge 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Okay. Now we are establishing the electric field between positive to negative. These two plates are separated by a distance of D. Okay. Air is the medium between the two. Now the electric field between the two plates is sigma by epsilon 0. Okay. So what is the formula we are having? Q by V. Okay. So how we can calculate Q? So surface charge density is defined as the ratio of charge to the unit area. So the division A comes to this side as multiplication A. So sigma A equal to Q. So we are having Q, we are having E. So what is the relation? We can go for dV equal to minus E into dx. So by substituting all the values and derive that one, so finally we can have C equal to epsilon 0 A by D. C equal to epsilon 0 A by D. So capacitance of the parallel plate capacitor is directly proportional to area and inversely proportional to distance. Okay. Now I am placing a dielectric medium. I am placing a dielectric medium between the two plates of thickness T. So the capacitance changes. So C dash equal to epsilon 0 A by D minus T plus T by epsilon R. So by using that we can calculate the capacitance of capacitor with the dielectric. So capacitance of capacitor with the dielectric. Okay, do you get it now? Okay, so now we are placing now the parallel plate capacitor is completely filled with the dielectric. So the distance between the two plates is D. The thickness of the dielectric is T. It may be plate A. Okay. It may be plate B. So where the outer plate is grounded. Okay. So now what happened? the capacitance is equal to epsilon A by D. For instead of epsilon, we can substitute C dash equal to epsilon 0 epsilon R A by D. So that it becomes C dash equal to epsilon R times of C. So we know that epsilon R is always greater than 1. So C dash is always greater than 1. Okay, sorry. C dash is always greater than C. So this one, how it is related with our problem. So the capacitance increases from 5 to 60. So 60 is the maximum. So that is the value of C dash. So C dash equal to 60 from 5. So it is taken as 5. We can go for microfarad. Is filled between the plates. The dielectric constant. So what is dielectric constant? Epsilon R equal to. So by relating these three, what may be the formula? C dash equal to epsilon 0 R into C. Okay. So C dash equal to epsilon R times of C. So what is the value of epsilon? C dash 60 equal to epsilon R into C 5. So 1 5 is 5. 12 5s are 60. So epsilon R equal to 12. So it is dimensionless variable. So that epsilon R equal to 12, which has no unit. Here I said epsilon R is greater than 1. That also proved epsilon R is always greater than 1. Okay. So some of you may be asked, sir, for instead of dielectric medium filled like this, when it is filled like this. Okay. Now its capacitance is C. Suppose its capacitance is C dash. Now it is filled with a dielectric. What happens? Now the distance between the plates for air is D. For dielectric medium is also D. Here the area becomes half. Here the area becomes half. Now what happens? Now the air and the dielectric medium are connected like this. So it is connected in parallel. So if it is connected in parallel like this, then the effective capacitance is epsilon 0 A by 2D into 1 plus epsilon R. So by using that, we can calculate the total capacitance of the capacitor. Okay, do you get it now? Do you need it out? Okay, so the capacitance of a parallel plate capacitor increases from 5 microfarad to 6 microfarad. When a dielectric is filled between the plates, the dielectric constant is dash. So C dash equal to 60 microfarad, C is 5 microfarad. Then to relate C dash equal to epsilon R times of C. So 1 5 is 5, 12 5s are 60. So epsilon R is 12. Okay. So now a parallel plate capacitor is filled like this. Okay. Now its thickness is T. Now the distance between the two plates is D. Here we are having air. It is a dielectric medium. So thickness of air is D minus T. Now the distance becomes half. So D by 2 and its distance is D by 2. But what about the area? So area nearly remains same. So the capacitance is 2 times of epsilon 0 A by epsilon R by 1 plus epsilon R. So now the capacitance becomes 2 times of epsilon 0 A by D into epsilon R by 1 plus epsilon R. Okay. Now when the dielectrics are filled, half filled like this, then it is said to be Now the capacitance is in air. Now with the dielectric. So now it is connected in series. Okay, so when the capacitors are connected in series, how it becomes? So 1, 2, 3. When it is connected with the source. Okay. Now the capacitance of the capacitor is C1 and its capacitance is C2 and its capacitance is C3. So from the source, the charge is flowing. When the charge flowing this one, so the charge will be same. Charge will be same. The source gives a potential of V. The potential drop across the first one is V1 and the second one is V2 and the third one is V3. So that the total potential V equal to V1 plus V2 plus V3. So what happened to the capacitance? So 1 by Cs equal to 1 by C1 plus 1 by C2 plus 1 by C3. Then finally we can say the effective capacitance is always less than C1, C2 and C3 when the capacitors are connected in series. On the other hand, we can connect the capacitors in parallel. Okay. When these are connected with the source, the capacitance of the first one is C1 and the capacitance of the second one is C2 and the capacitance of the third one is C3. So from the charge source is flowing. So the source, when it comes to this point, then it is divided into Q1 or split into Q2 and Q3. So all the terminals are connected at the same point. So potential remains same. Potential remains same. But the charge will be differ. Charge will be differ. So how the charge will be differ? Q1 plus Q2 plus Q3. Okay. What about the effective capacitance? So the effective capacitance in parallel equal to C1 plus C2 plus C3. So that we can conclude that the effective capacitance in parallel is always greater than C1, C2 and C3. Okay, do you get it now? So from the exam point of view, we can expect the combination of capacitors. Combination of capacitors. Okay. So let us consider the capacitor is a device used to store the charges. So how much charges are stored? How much energy is stored? Okay. So let us consider a parallel plate. The parallel plate is connected with the source. So that 1, 2, 3, 4, 1, 2, 3, 4. So it is used to store the charges or amount of energy is stored. So how we can calculate the amount of energy? So energy is epsilon equal to Q squared by 2C. Or otherwise, that is a half CV squared. Okay. Now, by taking this half C, we can go for difference. How we can go for the difference or different way of formulas or different form of formulas. Half into CS into V squared. Okay. For instance, CS, suppose when two capacitors are connected, 1 by CS equal to 1 by C1 plus 1 by C2. By taking LCM, so C1, C2, here it becomes C1 plus C2 equal to 1 by CS. Now reciprocal the value. So when we reciprocal the value, CS equal to C1, C2 by C1 plus C2. So CS equal to C1 plus C2 by C1 plus C2. Now we can substitute the value. So half C1 C2 by C1 plus C2 into V square. Now the capacitors are connected in parallel. So it becomes Cp equal to C1 plus C2. So how we can go for energy? So energy equal to half into Cp into V square. For instead of Cp, we can write C1 plus C2 into V square. Suppose we can go for epsilon 0 A by D into V square. epsilon 0 A by D minus T plus T by epsilon R into V square. So like that, we can substitute for capacitors. Then we can calculate the value of energy. Okay.